For those of you who want to see another example, here's another one of your homework questions. And I'm going to run through how to graph this thing real quick. So first of all, to account for any of the horizontal changes in the graph, we should set up and solve this inequality. So take exactly what's inside of your given trig function, your sine or cosine function, I should say. Put that between 0 and 2 pi. And again, we're doing that because we know that the graph of y equals sine x goes through one complete cycle as x goes from 0 to 2 pi. And the sine graph looks like this. It starts and ends at 0, and it does this sort of thing. Whoa, okay, roughly there. But so the important thing right now is you get the complete picture when x goes from 0 to 2 pi. So we're going to get the complete picture for this graph when all of that goes from 0 to 2 pi. Now to solve this inequality, I'd probably want to clear, well, I don't know, it's up to you guys. But since I didn't do it in the previous example, I'll take a different approach here for you guys who want to see something different. I could get rid of the denominators here by multiplying everything by the least common denominator. So that would be the least common multiple of 3 and 2, so 6. So for you guys who don't like dealing with fractions, you can clear them in the first step by multiplying every term by 6. Just make sure you multiply everything by 6. You don't forget and leave something out. It's only legal if you multiply every single term by 6. Otherwise, you're changing the inequality. So 0 times 6, that's still 0. 1/3 times 6, so that's 6 over 3 is 2. And then 6 divided by 2, that's 3. So this is 3 pi here now. And then 2 pi times 6, so that's 12 pi. Okay, and then I want to get to the graphing, so I'm going to rush through this a little bit. Subtract 3 pi from each part. So we have negative 3 pi less than or equal to 2x less than or equal to 9 pi. And then divide everything by 2 to get x by itself. Okay, so we're going to get one complete cycle as x ranges from negative 3 pi over 2 to positive 9 pi over 2. Okay, so what we should do now is mark those x values on our axis here. So I'm going to just single space this one. I'll call this negative 3 pi over 2. And then over here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's fine if you just label your first and last x values for your one cycle. Okay, so now here again I'm going to go back and think about the sine graph. So sine starts and ends at 0. So I'll plot those points. Sine starts and ends at 0. Right in the middle, you get another x-intercept in the sine graph. So I need to find what's right in the middle of negative 3 pi over 2 and 9 pi over 2. So this would be 12 spaces, right? Because there's 9 spaces over here, there's 3 spaces over here. So a total of 12 spaces. So if I just count over 6 spaces, 1, 2, 3, 4, 5, 6, this would be the middle. And it looks like the middle too, so that's always a good sign. That's going to be where the intercept goes. So 1, 2, 3, 4, 5, 6 here. So there's the middle. That's where I get that other x-intercept. Now another thing about the sine function. Between those first two intercepts, right in the middle of that first half, it reaches its maximum value. Okay. Now, I don't know how much you're willing to tackle at once, but this thing has a negative 2 in front. So that's going to do two things. The 2 is going to make the amplitude 2, and that's probably the one that's more obvious to you. The negative is going to reflect the graph. So instead of going up to its maximum in the first half, the graph is going to go down to its minimum. And because the amplitude is 2, it's going to go down to negative 2. So if I take this first half of the graph, divide it exactly in half, so let's see, that's 1, 2, 3, 4, 5, 6 spaces. So if I go over 3 spaces, 1, 2, 3, I'm at 0. I need to go down to negative 2. So there's another key point on the graph. I'm going to 2 because the amplitude is 2, and I'm going down instead of up because of the negative out front is going to flip this thing. And then in the second half, instead of going down to the minimum, it's going to go up to the maximum, which this thing has an amplitude of 2. So again, if I count over 1, 2, 3 spaces, this thing has an amplitude of 2, so it's going to go up to its maximum at positive 2 there. And so what I've drawn in red there would be the graph of this given function, -2 sine of 1/3 x plus pi over 2.